Good morning. I am Devi Abirami, Assistant Professor, Department of Mathematics. Today I am going to present a topic correlation in mathematics and statistical computation, which is a course for the commerce students in their second year. First, we should know what is meant by a correlation. The word correlation is used in everyday life to denote some form of association. We might have that we have noticed a correlation between foggy days and attacks of wheeziness. For example, in a cold climate, the children will suffer more from fever, cold, and cough, whereas in summer season, the affectness will be very low. So we can plot a correlation between those two combinations. We also assume that the association is linear. However, in statistical, we will use this correlation between two quantity variables. That one variable increases or decreases a fixed amount for a unit increase or decrease in the other. The variable cannot increase or decrease. The other technique that is often used in these circumstances is regression, which involves estimating the best straight line to summarize the association. To calculate this correlation, we will use a coefficient called correlation coefficient in mathematics. This correlation coefficient is denoted by the letter small r. It is sometimes called as Pearson's correlation coefficient after its originator. This correlation was invented by this person, Pearson. If a curved line is needed to express the relationship, other and more complicated measure of the correlation must be used. The correlation coefficient will vary from plus 1 through 0 to minus 1. The correlation lies between 0 to 1. The complete correlation between these two variables is expressed by either positive 1 or negative 1. Positive 1 denotes the positive correlation and negative 1 denotes the negative correlation. When one increases, that is, one variable increases and the other variable also increases, then the correlation is said to be a positive correlation. If it is vice versa, then the correlation is said to be a negative correlation. In next topic, we are going to see the types of correlation. The scatter plot explains the correlation between the two attributes or variables. It represents how closely the two variables are connected. There can be in three situations. One is positive correlation, other is negative correlation, and other is no correlation. Positive correlation in the sense when the values of the two variables moves in the same direction. For example, positive correlation, if the rate of the vegetable is low, then there will be a sales will be more. Okay. If the profit is more, then the work is also more. If the price is very high, for example, if the gold rate is very high, then the purchasing a gold will be very low. It will shows that the sales will be very less than the other one. So this type of correlation is said to be a positive correlation and it is denoted in a diagrammatic representation. Here both the x and y values are increasing in the same direction. Therefore, the scatter diagram is said to be a strong positive correlation. My next type is negative correlation. When the values of the two variables move in the opposite direction. For example, if the marks of the students is not belongs to the height of the student. If we take both the values, that is the height of the students and the mark, it will it will not be matched, exactly it will not be matched, then there will be a negative correlation. The negative correlation is plotted in this diagrammatic representation and it is known as strong negative correlation. Last one is no correlation. When there is no linear dependence or no relation between the two variables, then it is said to be a no correlation. As I have said already, the no correlation is the marks of the students, it does not belongs to their physical appearance. So there will be no correlation. In mathematics, we will calculate this correlation coefficient by using a simple formula R equal to summation xy. N means number of variables. Summation xy means sum of the xy, and summation x means sum of x variables alone, and summation y means sum of y variables alone, divided by square root of n summation x square minus summation x the whole square into n summation y square minus summation y the whole square. This formula is explained by giving a problem. My problem is calculate the correlation coefficient between the two variable x and y. My x value is 2, 4, 2, 6, 8, 10, 14, 16. My y value is 4, 12, 16, 20, 28, 32. By given value itself, it is understood that both the values are increasing in the same direction. So my answer will definitely in the positive value. For using this formula, I have calculated my xy value, x square value, y square value in the table format. And the final summation x value is given in the bold letters at the end of the table. Now I am applying that value in the formula. N is 6 because we are having only 6 values in the both x and y. So n is 6. Summation xy value is 1312. Summation x value is 56 and summation y value is 112. Similarly, I have entered all my values in my denominator. If I simplify this by using a calculation, my answer is 1.001. That is, my answer isn't positive. What I have told already is the correlation will lies between only 0 to 1. My answer is 1. Therefore, my correlation is a perfect positive correlation. I hope that you have understand my problem. Thank you. Thank you.